Okay, so welcome to the second phase of this training. I mean, the real reason why we are here, the hands-on. This screen you are seeing now is the homepage of SmartPLS. So when you download your software and you open it, this is what you will see. New project, PLS SEM, CB SEM. This is like this feature just came, I think, early this year. This one and then this. It was basically about just PLS SEM, but then they added covariance-based. Now, to run a very simple model, we're not going to make it very complex at all. And I mean, I know there are people from different academic background here, so we'll make it very simple. We just run a very straight model, and then let's just assume we are trying to study the effects of advertising on the patronage of a particular commodity. I won't be tempted to mention any brand. Effects of advertising on the patronage of a particular commodity. And then we've gone to the field, we've gathered we are ready to run time. This is part analysis and process, regression, and NCA, DLSM, multiple methods, GSCA. All of this, just feel free to go through it at your spare time, and then you can read them. But when you are ready to run analysis, the first place you go to is new projects. You click on new project, and then it will ask you to create a new project name. So for training. Oh, done that. Okay, let's just call it sample. Let's call it sample, okay? And then you create. Click on create. Please follow me. I'll be very detailed and I'll be very, very slow. I'm not going to rush this. This is why we came. Now, you go to your left part of the screen, you see that project you've created has been captured under your workspace, and you see sample. But under it, you see import data file, and then create model. So you click on import data file to now take you to where your data is. If it doesn't take you to exactly where your data is in your system, you can, of course, you know where your data is, so you can always search for it. But mine is already here, so sample data. I'll just click here, and I'll click on open. Please let me also say this: SmartPLS can receive data from multiple sources, data from SPSS software. So I've used data from SPSS, but we are going to use from Excel today. So you click here, and then you click open. And then let's see, you wait for some few seconds. It's loading. Here we are. It's loading. Now, the beauty is it already gives you a kind of, or the descriptive aspect of your data set. The minimum and maximum values. Putting data file, calculating statistics. It's loading. Yeah. So we can see this is like a descriptive statistics. You've seen the mean, you've seen the median, you've seen the scale mean, minimum, you've seen the scale maximum, observed mean, and number of data set type missing. There's no missing value. And so sorry, let me take this out from here. Okay, you now click on back. Click on back, and then you create model. Please, all of these are simple steps that you need to follow to get this done. You click on create model. So you choose your model type. Of course, the project name is sample. So you choose your. We come here. We are doing preparation. We are doing process GSCA. Okay, so we have 5 variables in this particular research, advertising on the concept, customer patronage of a particular brand. So we have this. You click on this, hold your shift key, use your arrow key, the down one, do 1, 2, 3. Now, if you can see the way I named it, this TA means television advertising. So television advertising 1, television advertising 2, television advertising 3, television advertising 4. It means that in your question, questionnaire, you had used 4 television advertising. Remember what we talked about during the theoretical section, the observed variables and the latent variables. So these are like the observed variables now. So you just double click on it and drag it down. When you drag it down, you click enter. Can we see? And then you come to where you come to the right hand side. You use this and then you turn it. Please, if I'm too radio advertising. So you have 1, 2, 3, 4. You can use your shift, press your shift key down, then use your arrows to move it and then highlight everything. Then you click on it. Bring it down, click enter. Do the same thing, it turns. Then you now come to arrange it, put circles together. So these are your letters. Now we come to advertising. This P is called print advertising. These 2 variables, right?
Mm-hmm.
Okay. Okay. Okay, so we have the next one for variables. Shift key, press down, double click, drag and drop. Click on enter. You click this and then come to where you have the arrow so that you can direct it. Yes, this is it. There's always a green line trying to show you that it's in alignment. The Latin variables are in alignment. So there's always a green line. It's just for it's in, we go to the next one. Social media advertising. Social media advertising. We have shift key. So we have done independent variable one, that's television advertising, radio advertising, that's two, print advertising, that's three, and then social media advertising, that's four. Four independent variables, you can call it four latent variables. Now the next one is the dependent variable, which is consumer patronage. So you see have four observed variables with your shift key and your arrow key, 2, 3, 4. Double click, drag down. Now, this is what I said while we're handling the theory class, the theory part, that you and what the dependent variable is, and where to keep what. So this is a dependent variable, and we cannot bring it down here. So we have to bring it here. This is a dependent variable. We are trying to look at the effect of advertising on consumer patronage. This is consumer patronage. So we bring this here. You see, that green line shows again. That green line shows again. So with this, you have arranged your variables. With this, you've arranged your variables. The next thing we do, this icon with this arrow, connect. You click on it. The blue sign of it will come on. Click and hold, then you drag it down. Click and hold. Then you drag it down. To blue, then know that there is a problem. If after clicking from your IV that there is a problem, know that there is a problem, and then we will now have to look for how to resolve that. We come here. I'm saying that because, while doing analysis, you may encounter it. So we come here, you click on this. You come here, you click on this. You come here, you click on this, and drop. The color changes. This was why I said that SmartPLS4 is SEM is you didn't draw any of this model. It was supposed that you would need to sit down and draw all of this one by one. For those of us that have done SEM for the past years, we can attest to it. You will draw this, you draw it, and you position. Before you are done drawing, imagine you have like 5 independent variables, then you have probably your model is a complex model with a mediating, moderating variable, and then then all of your light before you finish. But the beauty here is that this is done in split of ready. Okay, so now that we have this, we come to where we have calculate. Please look at this. Calculate. You click on calculate, and it will show you PLS, and bootstrapping. Remember, we had talked about two kind. We had talked about the structural model, and we had talked about the measurement model. Where we're talking about the terminologies in SEM. Now, for the measurement model, you use PLS algorithm. This will give you the measurement model. It will show you the of your instrument, to tell you about the reliability of your instrument and every other thing that you want to see about your survey tool. So this is for measurement model. So you click on this, and then a table will appear. In a few seconds, the table will come up. Don't touch anything, just calculate. And it does this in few seconds, and the results will be out. And whoa, so here we are. Now, please, structural model. This is your measurement of this on this. No, this does not. Okay, so when you go to PLS algorithm, you click on PLS algorithm, it will show you a dialog, a, a box in your screen. Calculation model for you in split of seconds. It's ready. Now, please don't confuse this as a structural model. This is not the structural model. This model doesn't tell us the effects of all of these IVs on the DVs. No, this is the measurement model. Now, what we should look out for in this measurement model are this. Now, if you come down to the left part of your screen, you'll see structural model, measurement model, construct. Now, this part coefficient, you click on part coefficient, you'll see different options here: correlation, covariance, but you will not see significant level. You will not see P value. What this tells us is that this model here, it's not the structural model that shows us the effects of independent variable on the dependent variable. So what we are looking out for here is we come to part coefficient. You see, this is part coefficient matrix. Come to total effect, outer loadings. Now, one thing I love saying about this is know what you want to report, know what table that you need in your either your research work or your article. All of these tables here means different things. So, but know which one you want to capture in your work. we have this construct reliability and validity. This is what I was telling us about. Cranbach alpha, composite reliability, RHOC, and average variance extracted. This average variance extracted is one unique thing that SEM does for SmartPLS does for us effortlessly. Now, before now, people that have used other softwares to do SEM, you will calculate this manually. This will be there's a formula for it. Yes, there's a formula to calculate average variance extracted. But the beauty of SmartPLS is it does this for you effortlessly, and the threshold is 0.50. And you can see that the color is green. If you see anything it shows you there's a problem. This is your Cranbach alpha composite reliability. Print this just here to your Microsoft. Just here to your Microsoft, and then you're good to go. The next one we have is discriminant validity. I know most of us have used different, we have gone online and seen different research works with this table as far as SEM is concerned. Discriminant validity. And then we have the fund. Discriminant validity also. Now that all the value greater than the ones under. Now, if there's any value under that is greater than any one up, you will see a rate column. So all the values here have to be greater. Like you can see, our discriminant validity is sorted out. 0.79, 0.81, 0.78, 0.81, 0.78. You can go to VIF, polarity statistics. Go to VIF, and then you see. Then we come to model fit. This is another table that most people always also capture in their interpretation. I'm just showing us different analysis with SmartPLS. Now, whatever you want to capture in your interpretation, all you need to do is just click on that table, copy it, and take it to Microsoft and do your interpretation. Whatever you want, whatever table you want in your interpretation. So we can, this is for discriminant validity. Oh, I didn't show F, where is it? F squared. You can see this is F squared. And then R squared. All of this outer weights. Now this is outer weights. Outer loadings. This outer loadings is the same thing as what you have here. Same thing as what you have here. Let's go back to outer loadings again. 785. Outer loadings. If you come to TA, you see that this is 0.785. And then if you come here, 0.785, 0.852, 0.731, 0.3, 0.780. Now you can decide to bring this outer loadings table and just interpret that it shows the individual contribution of each construct or observed variables as to the Latin variables. So you can bring this and then you just copy it, drop, and run your interpretation. It shows that all the observed variables actually contributed very well to, measuring the Latin variables. So you have 0.73, 0.81, 0.794, 0.840. Now we move from here to the next one, which is the structural model. So this basically is the measurement model. So we move to structural model. You click on edit, and it will take you back. Then you come here, you click on calculate, and then bootstrapping. Now, when you're doing structural model, you use bootstrapping, and then you click on bootstrapping. For a few seconds, this will come up. Please be very careful with this particular pop-up screen. Because if you don't, you may not have the right results. You come to where you have most important, and then you change it from faster to slower. Change it from faster to slower, complete slower. Let it run a very detailed analysis and very slow. So you can click on save result as a sample, and then this is to tell, leave everything the way it is, and click on start calculation. In a few seconds, the result will be out. It's calculating, running different analysis. Okay. I want. Okay, so this is the model that shows us the effect of the independent variable on the dependent. The discourse we had here during the when we had the measurement model, it now shows us that this one's here now, this 0.00 being the normal scores the normal So this is the model. Now, this is the P or significantly affects the how do I put it now? Okay, let me say television there is a significant effect of television advertising on consumer patronage. There's a significant effect of radio advertising on consumer patronage of that particular group. Like I said, we're not going to use any brand. There's a significant effect of print advertising on consumer patronage, and then there's a significant effect of social media advertising on consumer patronage. How do we know? This is our p-value. These are significant value. These are p-value. Now remember that when it was the measurement model, we didn't have this p-value in this structure. But now, can we see p-value and part coefficient?
Sorry, say that again. You said when we had the measurement model, we did not have what value?
When it was the measurement model, we didn't have p-value. We didn't have this during the measurement model. We had every other option, but there was no p-value. Now that is a structural model, the very model that shows us the effects of the independent variable on the dependent variable. We now have the p-value, which is all of this scores you're seeing here. Now you can decide to have the p-value. Of course, I'm sure most of us have seen a model like this that has two different values here. That's the p-value and the part coefficient. You can have this, the p-value and the part coefficient. Now, if I want to have the reliability scores, all of it here, I can just click on this and it will all change. These are now all the reliability values. If I want just the R square value, just this R square. Adjusted R square, just this. So it shows you the beauty of SmartPLS is with this model alone, with this model, I wouldn't need to have Chromback alpha values here, because this alone will tell me with these values here, I will know, okay, your survey tool had passed the reliability and the validity test. To have this scores here, all of these observed variables values, it shows me that your survey tool was good. So I wouldn't need all of these values in the middle. So I'll just leave it at, let's say, R adjusted R square value. So this is the model that you can copy. Just export image. You can export this image straight to Microsoft, and then you start your interpretation. What does this mean? This means that there is a significant effect of television advertising on effect of radio advertising on consumer patronage. This means that there's a significant effect of print advertising on consumer patronage. How do we know? This is their p-values. This is their p-values. This is their p-values. This one is the part coefficient. Part coefficient. This is their p-values. This here is like the path coefficient of the observed variables, and this is their p-values also. This is their p-values. So this is very simple. Now, most journals would not want to turn away an article done with structural equation model analysis at the article and then back it up with a SEM analysis. All they want to see is, because you cannot actually edit this. This is an image. You cannot edit this. You cannot edit this. This is an image. So if it is not valid, it's not valid. If it's not good, it's not good. You can't edit any of these scores. So for you to prove sincerity to the editor or to your reviewer, just bring all of this. Leave it the way it is, so that they will see that, okay, this is the contribution of the observed variables with this. Oh, okay. That means the questionnaire or the survey tool had passed the reliability and the validity testing. And then you go back to your measurement model and export that validity and reliability table. Take it to Microsoft, where you have the Chromback alpha and then the average variance extracted at the end. That particular table also is a very good table to be used for your article, even your so please, I would love us to pause the recording.
Yeah, say the last sentence again. The last sentence you made. Can you say it? Because it broke.
I would love if you do a SEM analysis for your article. This cannot be edited in any way. All of these figures, this is a picture. So you right click, export image. Excuse me. You export image. Now, when you produce this kind of image, it shows some level of sincerity on your part as a researcher. Now, the editor or the reviewer will see all of these values and know that, okay, this survey tool actually passed the reliability and the validity test. With all of this, the reviewer will want, or the editor will want to consider your article or your paper for further review. So this is not like, let's say, regression that you can actually copy the table and start manipulating it on Microsoft. You can't manipulate this one. You can't manipulate this one. And then if you want to extract or copy the table in your measurement model and go and manipulate, when you bring in your structural model, especially for the reliability, it's going to tell here. It's going to tell here. It's going to tell here. If this is not good, then your reliability cannot be good. Your validity cannot be good. It's going to tell here very well. So this is one statistical tool that you should use in your next publication. Thank you very much. I don't know if we've gotten to this point. I'd love us to pause the recording at this point and then take questions and reactions. Thank you.